Hi everyone, welcome to Math. Today we are going to study chapter 6 triangles, exercise 6.2 question 8. Using theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So first of all, what is using theorem 6.2? We'll understand 6.2, theorem 6.2. When I did introduction, I have explained to you the theorem 6.2, that is nothing but converse of basic proportionality theorem. So I'll explain to you here in short that the theorem 6.2, okay, theorem 6.2, that is converse of basic proportionality theorem, okay, that is theorem 6.2. What does it say? It says that if you have a triangle ABC, okay, if you have a triangle ABC and if you have this, both the side ratios are equal, take one point here and another point here and then draw a line, okay, then we name it E and F, okay. So AE upon EB equal to AF upon FC, okay. If these ratios are equal, then these lines are parallel. So if this is equal, ratios are equal, then EF will be parallel to BC. So if these two sides ratios are equal, then the lines are parallel. So that's what theorem 6.2. So that's what we have to prove here. If the ratios are equal, then the lines are parallel. So you see, prove that the line joining the midpoints of any two sides of the triangle is parallel to the third side. So that's what we have to prove. First, let us draw a triangle. This is our triangle and let us name it A, B and C, okay. So prove that the line joining the midpoints of any two sides. So let's take any two sides and we take the midpoint. So let's consider this is the midpoint of one side and this is the midpoint of the other side, okay. I'll give the other. This is the midpoint of this side and this is midpoint of the other side, and let's name it D and E. Okay, now prove that the line joining the midpoints of any two sides of a triangle. So joining the midpoint. So let's join. Okay. So joining the midpoints of any two sides of the triangle is parallel to the third side. So we have to prove. Now these two sides, the midpoints joining the line, that line, we have to prove that parallel to the third side. Okay. So this is our first side, second side and third side. So first two sides of the midpoint. So joining the midpoints of any two sides. So any two sides joining the midpoint of a triangle is parallel to the third side. So this is parallel to the third side, that is BC. So that's what we have to prove. So let's proceed. So what is given to us now? What is given? It is midpoint, right? If this is midpoint of this side, means this AD will be equal to DB. So AD is equal to DB. Okay, so now this is the midpoint of the other side. So that means AE will be equal to EC. Okay, this is what given to us because these are the midpoint, it is said. So this side will be equal. Okay, now what we have to prove is, we have to prove that DE is parallel to BC. So this is what we have to prove. So let's begin the proof. Okay, so now in triangle ABC, in this triangle, what is given to us? AD is equal to DB and AE is equal to EC. So this is what given to us. So let's consider this as equation 1. Okay. So now we have to prove this ratio, right? So let's take this side of, okay. So ratio, that is AD upon DB. We have to prove that these ratios are equal. Okay, so first we'll take the first ratio, that is AD upon DB. Okay, so now AD upon DB. Now let me write AD. AD value, you see, AD is equal to DB. So instead of AD, we'll write DB. Okay, and this DB as it is. Okay, why? Because given AD is equal to DB. Okay, so now AD upon DB. These two get cut, means we'll have 1 here. So let's consider this as equation 2. Okay, so same way we'll write down the other side also. So now the other side of the ratio, AE upon EC. AE upon EC, okay, is equal to, now AE is equal to EC, so EC upon EC. You can write down, given that is AE is equal to EC. Okay, so instead of AE we'll write EC, then denominator same, so gets cut here. So we'll have AE upon EC equal to 1. Equation 3. Now from equation 2 and 3, you see this right side all same. So 1 is equal to this also, 1 is equal to this also. So that means these two will be equal to each other. So from equation 2 and 3, from equation 2 and 3, can we say that AD upon DB is equal to AE upon EC. Okay, so AD upon DB is what? AD upon DB is equal to AE upon EC. AE upon EC. So we have proved that these two sides ratios are equal. So if the ratios are equal, then by converse of BPT theorem, can we say these lines are parallel? That's what the theorem says. If the ratios are equal, then the lines are parallel. So we have proved that the ratios are equal. Therefore, by converse of basic proportionality theorem, we can say that DE is parallel to BC. Hence, proof. That's it. Thank you and God bless you.